Hello students, today's discussing topic is electric charge. Then now let us enjoy it. What is electric charge? Electric charge is an intrinsic property of a material due to which it causes to experience a force when it is placed in an electromagnetic field. Okay. What is electric charge? Electric charge, an intrinsic property of a material which causes to experience a force when it is placed in an electromagnetic medium. Okay. Then what is the properties of charge? What is the properties of charge? Now properties of charge. What is the properties of charge? Its properties first, charge is conserved. What does it mean? That it means it follows the law of conservation of charge. What does it mean? It means in an isolated system, a charge can't be created or destroyed. This is the law of conservation of charge. What does it mean? It means charge neither created nor be destroyed at any cost in an isolated system. Suppose this is a particle and now this is neutral, electrically neutral. What does it mean? It means net charge is equal to 0. That is, number of protons is equal to number of electrons. Okay. This is electrically neutral. In the second scenario, suppose consider this particle and this and thus another object. This is object 1 this is object 2. Suppose initially the number of, just one moment, suppose this is material 1 and this is material 2, and here number of protons is equal to 5 and the number of electrons is equal to 5, and here number of proton is equal to 6 and the number of electrons is equal to 6. Here net charge is equal to 0. Here net charge is equal to 0. Now, and when we consider in total this system, this is system, and system net charge of system, and this is isolated system, isolated system is equal to 0. Okay. Then second scenario, if we consider, suppose that now suppose one electron enters into this. Now number of proton is equal to 5 and number of electron, this is 4 and this is positive charge, +1 charge, and this is, there exists deficiency of 1 electron and there exists surplus of 1 electron, and here number of proton is equal to 6 and the number of electron is equal to 7. So, here there exists -1 charge, and when we regard net charge of an isolated system, this is 1 + 1 -1 is equal to 0. Then what we see? Before, at the first case net charge is 0 and the second case net charge is 0. That means, in an isolated system the net charge always constant. It is the law of conservation of charge. And what is isolated system? Isolated system what is isolated system? Isolated system is the system, isolated system is a system of charges, or universally we say it isolated system of surroundings which can't exchange matter, that is mass or energy. In other words, say this is an isolated system What does it means? This is closed system. What does it mean? Neither it exchanges or may permit exchanges mass nor exchanges energy with the surroundings. So, this is the concept of conservation law of charge, conservation of charge. That means charge is always conserved. This is the property of charge. Okay. The second property of charge, quantization or atomicity of charge. This is quantization of charge, or in other words we say atomicity of charge. What is this? For this we should know at first elementary charge, or second name is fundamental charge. What is this? What is this elementary charge or fundamental charge? This is the least amount of charge. This is the least amount of charge. Okay. Because lesser than this amount we can't take, we can't imagine, and it is denoted by E, and its value is 1.6 into 10 to the power minus 19 coulomb for electron, proton, and E is equal to minus 1.6 into 10 to the power minus 19 coulomb for electron. That means the amount is same, this is amount of charge, this is same 1.6 into 10 to the power minus 19 coulomb, and for electron also 1.6 into 10 to the power minus 19 coulomb. Just to denote it, this is positive which is not written, and this is negative for electrons. And this E, this is the least amount of charge, okay, and it is known also fundamental charge. This is denoted by E. Okay. Now, quantization or atomicity of charge, that means when we say a certain body is charged, certain body has Q charge. Suppose this body this is Q charge, then this charge is denoted in the terms of E, and how should it denote? The integral terms, integral multiple of this very charge, this is denoted as integral multiple of this fundamental or elementary charge. Okay. What does it mean? Does it mean what does it mean? It means Q is equal to plus minus NE, where this N is an integers. Okay. And now this, suppose this value, this integral value is, or maybe dot 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 minus 1, 0, plus 1, plus 2, and so on. That means we take charge 0 E or minus 1 E, 0 E, plus this E, plus 2 E, plus 3, and so on. But on the other hand, we can't take it minus 0.5 E, 0.9 E, or 1.5 E, and so on. So that means, what does it means? We can't take fractional value. This property is called quantization of charge or atomicity of charge. Okay. This property of charge is called quantization or atomicity of charge. What does it mean? I can't take discrete continuous value, it always deserve discrete value. Okay. So this is the fundamental properties of charge. Okay. We know it well. There are some properties related charges. First is called conservation law of charge. That means we can't create charge nor destroy charge. Neither we create charge nor destroy charge. What does it mean? The summation of charges is always constant. In an isolated system, net charge constant. This is the law of conservation of charges, and it means charge is conserved always in an isolated system. And second is quantization or atomicity of charge, which is the property of charge. Suppose this property, due to this property, charges is expressed always as a discrete value. We can't take fractional value, complete integral multiple of amount of charges. Okay. Students, I hope this video is helpful for you. Even so, if you feel some problem or doubt, you may comment. I will try my best to sort out your comments, your doubts. Okay. All the best, students.